The problem I chose was number 11 from 7.1 for circular and rotational motion. So the question asks, a typical running track is an oval with 74 meters diameter, half circles at each end. A runner going once around the track covers a distance of 400 meters. Suppose a runner moving at a constant speed goes once around the track in 1 minute and 40 seconds. What is her centripetal acceleration during the turn at each end of the track? So what we're trying to figure out is the centripetal acceleration on the curve. So if we draw out a track just for it to make more sense to us, that was a really bad track, I'll redraw that. Make it nice and circular. We know that the distance all the way across here is 74 meters, and we will need the radius, so we know that that will be 37 meters is half, so that is the radius. It's 37 meters. Just to draw it out, and we want to know the acceleration around this curve and this curve. So the first thing we need to do is figure out the speed of the runner. And to do that, we know that it would be 400 meters per 100 seconds. Because a minute and 40 seconds, which would be 60 seconds plus 40 seconds, is 100, which makes it nice and easy to say that this runner travels at 4 meters per second. And then we already figured out the radius. So this is the speed. And then the radius, we know, is equal to 37 meters. And then to find the centripetal acceleration, we're going to place this into the equation that we have set. So acceleration is equal to the speed squared over the radius. And so then we can just plug that in. We can do 4 meters per second squared divided by 37 meters. And if you calculate that all out, we're going to have 16 meters per second squared over 37. And then we figure out that that is equal to 0.43 meters per second squared. And that is the centripetal acceleration around each of those curves that are 37 meters.